In this video, we're going to do an example of sketching a polynomial based on its factored form. Alright, so we see that we have the polynomial f of x equals x plus 4 times x minus 1 to the 5th times x minus 6 to the 4th. From this, we see that the x-intercepts are negative 4, 0, 1, 0, and 6, 0. We can see that from the factored form of the polynomial. To give us another point on the graph for reference, we know that if we plug 0 into the function, we get out negative 5,184. So that tells us what the y-intercept of the graph is. 0, negative 5,184. We can use the multiplicities here to tell us about whether or not the graph will cross the x-axis at the 0 and whether or not the function flattens out at the 0. So looking at negative 4, the multiplicity is 1. That's an odd multiplicity, so it crosses the x-axis. It's not bigger than 1, so it does not flatten out. For the 0 of 1, the multiplicity is 5. So the graph crosses the x-axis since it's odd, and it does flatten out since it's greater than 1. Finally, the multiplicity for the 0, 6 is 4. So the graph does not cross the x-axis because it's an even multiplicity. And again, the graph does flatten out. So here's a very, very rough sketch of what this has to look like. Another piece of information that we could have used. Notice that the degree of the polynomial is 10. 1 plus 5 plus 4 gives you 10 for the degree. And the leading coefficient is 1. So the leading coefficient will be positive and the degree is even, which tells you that both tails of the polynomial point up. So that's another useful piece of information to be able to sketch the graph. I come from upper left. I cross the x-axis at negative 4, and I do not flatten out. I have to come down and hit the y-intercept at negative 5,184. I cross the x-axis at 1, and it does flatten out. It also just kisses the x-axis at 6, so that means it flattened out since it kisses it. So it has to come down and kiss it and go back up again, and then that right tail should also point upward.